Take a close look at the wording of the question. It asks which statement is most likely supported by the data. That does not mean what must be true. It means what the data makes reasonable, not certain. On the SAT, most likely does not mean certainty. You are not asked to prove what must be true. Instead, the test rewards answers that are best supported by the data. That means you should eliminate choices that go beyond the evidence, and choose the one that is strongest, not absolute. Keep that mindset in mind as we move into practice. Alright, let's start with our first beginner practice question. Take a look at this two-way table. The question is simple. Which group has a higher yes rate? Don't rush to the numbers yet. Before calculating anything, think carefully about what yes rate actually means. You have 60 seconds. Pause the video, study the table, and make your choice. Now, let's go over the answer to beginner practice question 1. At first glance, it may look like Group B has more yes answers. But on the SAT, raw counts are not what matter. What we are comparing here are rates, not totals. That means we must look at the number of yes responses relative to each group's size. For Group A, there are 48 yes answers out of a total of 60. For Group B, there are 70 yes answers out of a total of 100. So the key step is choosing the correct denominator. When you compare yes rates within groups, the denominator must be the row total, not the column total. This is one of the most common traps in two-way table questions. The SAT is not testing your ability to calculate. It is testing whether you have the discipline to choose the correct denominator before you calculate. Alright, let's move on to beginner practice, question 2. This question looks very similar to the previous one, but the focus is different. So be careful. Now, let's walk through the answer step by step. The key word in this question is yes. That word tells us exactly how to think about the table. When a condition is given, we must fix that condition first. Here, we are conditioning on yes, so our attention goes to the yes column. Once the condition is fixed, the next decision is the denominator. And this is where many students make mistakes. The denominator is not the total number of students in each group, and it is not the grand total of the table. Because the condition is yes, the correct denominator is the column total for yes, which is 118. From that column, we then look at how the yes answers are distributed. Group A contributes 48 yes answers, and Group B contributes 70 yes answers. So every probability in this question is based on the same denominator, 118. And that's the core idea. When a condition is given, let that condition choose the denominator for you. The math itself is simple. The challenge is discipline, slowing down, identifying the condition, and using the correct total before doing any calculation. Now let's move on to question 3. This question asks, Are the two variables independent? Take a moment and think carefully about what that really means. Independence does not depend on the raw counts. It depends on whether the rates change from one group to another. So here's how to think about it. Compare the yes rates in Group A and Group B. If those rates are the same, the variables are independent. If they are different, they are not. Don't rush into calculation yet. First, decide which rates you need to compare, and which totals should be used as denominators. You have 60 seconds. Pause the video here, and try it on your own. Alright, let's walk through the answer together. The question was whether these two variables are independent. And the conclusion is clear: they are not independent. But what matters most here is why. Independence is not about the counts themselves. It's about whether the rates stay the same across groups. So instead of looking at totals or raw numbers, we compare the yes rates within each group. For Group A, there are 48 yes answers out of 60 students. For Group B, there are 70 yes answers out of 100 students. Notice what we're doing. In both cases, we fix the group first, and then use the row total as the denominator. Once we do that, the result is obvious. The yes rate in Group A is different from the yes rate in Group B, and because those rates are not the same, the variables cannot be independent. This is a classic SAT trap. The table looks similar at first glance, and many students stop at the counts. But the SAT is not testing arithmetic here. It's testing whether you know what to compare, and which total belongs to which question. Remember this rule: if the rates change across groups, independence is broken. That single idea will save you from many mistakes in two-way table questions. Now let's move to an intermediate question. The key phrase here is most strongly supported by the data. You are not asked what must be true, and you are not asked to explain why something happens. Your task is simpler, but more subtle. Look at each statement and ask, does the data support this, or does it go beyond the data? Alright, let's go through the answer carefully. The correct answer is A. This question asks, which statement is most strongly supported by the data? That wording is critical. You are not being asked what might be true. You are not being asked to explain why something happens. You are being asked to choose the statement that the table supports most directly, with the fewest assumptions. Why A is supported by the data? Choice A makes a clear, testable claim that one group is more likely to answer yes than the other. To evaluate that, we compare yes rates, not yes counts. For Group A, the yes rate is 48 out of 60. For Group B, the yes rate is 70 out of 100. Once the denominators are fixed correctly, the comparison is straightforward. Each group is evaluated within its own total. This is exactly the kind of claim the table is designed to support, a direct comparison of rates between groups. That is why A is the strongest statement supported by the data. Why the other choices are not supported. Now let's eliminate the other options one by one. Choice B talks about no rates. While you can calculate no rates, this statement shifts the focus away from the clearest comparison the table invites. It is not wrong math, but it is a weaker, less direct conclusion than comparing yes rates explicitly. On the SAT, most strongly supported means the cleanest conclusion, not a secondary one. Choice C uses causal language. Answering yes causes students to be placed in Group B. This is an automatic elimination. The table shows association, not causation. There is no experiment, no intervention, and no timeline. Any answer choice that claims cause and effect goes beyond what the data can show. Choice D says that most students in both groups answered yes. This sounds reasonable, but it is written vaguely. Most must be checked within each group, not from the totals at the bottom of the table. On the SAT, statements that sound true but rely on loose interpretation are often traps. If you have to reinterpret what most means to make the statement work, it is not strongly supported. Final SAT takeaway. Here is the key lesson. When you see most strongly supported by the data, stay inside the table. Use the correct denominators. Avoid causal language. Choose the conclusion that requires the fewest extra assumptions. That discipline, not calculation speed, is what the SAT is testing. And that is why the correct answer is A. Now it's your turn. Read the claim carefully, then check what the data actually support. Don't jump to conclusions based on counts. Ask yourself, which denominator matches the claim? Take your time and choose the best answer. Alright, let's go to the answer for advanced practice. The correct answer is B. Here's the key idea. The administrator's claim is based on counts. They're looking at the number of students who answered yes. And yes, Group B has 70 yes responses, while Group A has 48. But this is the trap. When group sizes are different, counts don't measure performance. Performance has to be compared using rates, in other words, the percentage within each group. So we lock in the denominator correctly, we use the row totals. Once that decision is made, the math is immediate. Group A has 48 yes responses out of 60 students. Group B has 70 yes responses out of 100 students. The comparison is clear. Group A's yes rate is 80%. Group B's yes rate is 70%. So even though Group B has more yes answers in raw numbers, Group A actually has the higher yes rate. That means the administrator's claim, Group B performs better, is not supported by the data. Now, why do the other choices fail? Choice A uses an overall comparison that doesn't match the claim. It mixes groups together and ignores the fact that the groups have different sizes. Choice C uses causal language, causes, and this table can't prove cause and effect. And choice D says we can't compare performance, but we can. We just did it correctly using rates. So the takeaway is simple. Separate the claim from the evidence, and let the denominator match the claim. On the SAT, that discipline matters more than the arithmetic. Before we finish, let's summarize the key takeaways from this lesson. First, always read the claim before you look at the numbers. Ask yourself what is actually being compared. Second, remember that counts can be misleading. When group sizes differ, performance must be measured using rates, not raw totals. Third, make sure the denominator matches the claim. If the comparison is within groups, your denominator must come from within those groups. Fourth, never confuse association with causation. Tables can show patterns, but they cannot explain why those patterns exist. And finally, slow down before you calculate. The SAT is not testing your arithmetic, it's testing your judgment. Choose the right denominator first, and the math will take care of itself.